So you can see here the current here is 1 amp, here is 2 amps, here is 1 amps. So after applying the KVL, we should get the same result. So what is KVL? KCL, we write down for KCL is the summation of all current in particular node is 0, right? For KVL is nothing but you can see Kirchhoff's current law, Kirchhoff's voltage law. So then it should be summation of voltage should be equal to 0, right? Here I write down summation of voltage. That means it cannot be in a node. It would be in the loop. So in a particular loop, the voltage summation is equal to 0. That means the sum of all the voltage drop. I mean this voltage drop, this voltage drop should be equal to 0. So this is KVL. So how we will apply? So here you can see we have two loops, right? So we need to apply KVL in this loop and this loop. Okay, how we will apply? Let's see. So here we have two loop. This is the loop 1. Can write down loop 1 and this is the loop 2, right? Just like in the KCL, we assume the node voltage, right? Here we will assume the loop current, okay? So here we assume this loop current is I1 and this loop current is I2, okay? At the KCL, we told you that whenever we apply the KCL, the node voltage should be max, right? Here also I say the same thing. Whenever we will apply KVL, the loop current will be high at that particular loop, okay? So now applying KVL in this particular loop, okay? So what we will get? We will get 15. This is the voltage drop as this current is this direction, right? So that means current is going from here to here. And what will be the value of current is I1, okay? So this will be the voltage drop. And in this particular 5 ohm, the current will go from this direction is I1. And for this loop, the current is going in the direction, that means I2. Okay, so we can write down 15 is the, this is plus, this is minus, right? And then you can say minus, plus, plus, minus. So current, the sign should be opposite. Minus 5 into I1. Okay, minus 5 into what? I1 minus I2. Why? As we assume that in this particular loop I1 is high. As I1 is high, then that means I1 minus I2, okay, equal to 0. So this will be equation 1. And if we apply KVL at loop 2, we will get this will be plus minus and this will be plus minus. Why? As we assume the current is high I2 in this particular loop. Okay, so we can write down plus minus, right? As there is no voltage source, so we can write down 5 I2 minus I1 plus 5 I2 equal to 0. Okay, now we get two equation and we have two variable. So if we solve this two equation, we will easily get the value of I1 and I2. Okay, so what we will get? For this one we will get, so from here we get 10 I2 minus 5 1 equal to 0. Okay, so if we simplify the equation 1, we will get 15 minus 5I1 minus 5I1 plus 5I2 equal to 0 equal to 15 will be 10I1 minus 5I2. Okay, so now just if we multiply this one by 2, then what we will get? We will get, then this 10I1 will cancel out, right? If we just add, then we will get 20, 15 I2 equal to 15. Then I2 will be 1 amps. Okay, and if I2 is 1 amps, if we just put this one in this particular equation, equation 2, then what we will get? We will get I1 will be 2 ampere, right? Now you can see after using the KVL also we get I2 equal to 1 amps. That means this current is 1 amps and this current is 2 amps. Okay, so we can say what will be the value of this current? This current will be 2 amps and 1 amps, right? So this will be 1 amps. Okay, so you can say it's very easy, but I will give you a suggestion. You can see here by solving this circuit, we need to solve two particular equation, right? As we have two current, right? But when we apply the KCL, you can see we can solve it by easily with the only one equation. So I will suggest you whenever you can see a circuit, just apply the KCL as KCL is the most easiest one. Do not apply KVL. Okay, why? KVL will give you more number of equation, as number of equation of KVL depend upon the number of loops. Okay, and here you can see we have two loops. Okay, but when we apply the KCL, we have only one loop. Okay, so whenever you saw any circuit at that time, please apply KCL. That's why we apply KCL for the op amp diode. Okay, but transistor, we don't know the voltage of the nodes in the transistor, so that's why we cannot apply the KCL at the transistor. So we need to apply the KVL. That's why we can see the calculation is much bigger. Okay, so we solve a particular circuit and we got the data I1 equal to 2 ampere, I2 equal to 1 ampere with both KCL and KVL. Okay, so that's all for today's class. In next class, I will start to import very important theorem is the Thevenin and Norton. But I tell you one thing, for both of this theorem also, we need to apply KCL, as KCL is the basic one. So please practice the KCL. Okay. If you do not do that one, when I will solve the Thevenin and Norton, you will be in the trouble. Okay. So at that time, you need to go back and see the KCL again. Okay. So that's all for today's class. See you in the next class. Good night. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.